Good afternoon, Miss Bethel. Me and my partner Gabriel Malanday are going to present our very own code designated to answer the users of different set operations. So we will gonna today see our code. First, we used include OpenCV2 and OpenCV.hpp. The purpose of these libraries is to open a file or image inside your system, like in the containing folder of your code. Here are the images that we were gonna use. We were gonna tackle this about a moment. Then using namespace CV, then the purpose of this is for the open CV, and we use include IOStream and CSTD Live. So it will be standard library, then using namespace STD. And first, we use string for the answer. So as you can see, here are answer, then answer two, then answer three, because there are three sets. This answer one belongs to first case, then this answer two is belongs to second case two, then the answer three is for case three. Then here I put attempts like equals to four because I'm gonna use while loop, and string again for the do while, and int for the enter. So first, we use do. Here is the syntax of do. Wait, so here. So if the user input y, it will gonna appear
Your screen.
their screen again to answer them for the first set. So here we use system CLS for the clear screen because we will gonna do loop, so it will gonna come clean.
The
Then
user will
system
choose.
color E4. So this E4 is the first letter is for background and the second number is for font. So E is yellow, then 4 is red. And then C out, here are the list of case. So each case here has a set operations. First is union of sets, second is intersection of sets, three subtraction of sets. Then the user will enter to proceed in the switch case. So if the user is inputted one, it will outputted the case number one. So we use while attempts. While attempts is not equal to zero, it will continue to answer the user. So if the answer is correct, it will gonna see out the designated output. Then else, if the user inputted the wrong answer, it will decrement its attempts by one. So if the user's attempts is equals to zero, you exceed in the limit and try again. Then it will break. That's the same in the case number two and case number three. We use the same syntax and logic here, but the difference between the three of them is the set operations of the Venn diagram. So first, Gabriel Malanday will explain this code.
So in case number one, we use while loop so that whenever the user will input a wrong answer, it will restart and ask the user what is the correct answer of this. So the program will give three set. We use A, B, and C, and the program will also provide a universal set. And the program will ask the user what is A union B intersection C complement. The user must input the correct choice so that the program will proceed to another test. So if the user will answer the correct, it will output an image or the Venn diagram of the correct answer, and it will ask the user if he or she wants to answer again. So let's proceed to number two, same as number one. We use while loop so that if the user will answer the wrong answer, it will restart the number, and it will also output the same as number one. We use set G, H, and Y. So for example, it will ask what is G intersection Y union H complement. So if the user will answer the wrong one, it will reloop to the same number. So if user will answer the correct, it will also output a Venn diagram image of that set operation. So let's proceed to number three. The number three is same as number one and two, is while attempts is not equal to zero, so that it will loop when the user will answer the wrong variable. So we use the set k, o, and I, and the program will ask the user what is k union o minus I complement. So the set operation we use is subtraction of a set. The program will ask the user what is the correct answer, and if the user will answer the correct one, it will output a Venn diagram image of the correct answer. Okay, let's proceed to Jal.
So we will gonna run the code if this works. We will gonna enter full screen. So the user will choose what set of operations he or she will gonna answer. So first we will gonna proceed to set operation number one, union of sets. Then this, then the answer in this block of code is or question is D. So if I enter the D, we're gonna see out an image. This is what I'm talking about before. That we're gonna see out an image. So this is the Venn diagram of the D. And if I X this, it will gonna, do you want to answer
It will
again?
gonna ask. Uh,
Then
let's try to answer a wrong variable. I-
it will gonna start again the program. So the user should be answer for this question. If the user will answer the wrong one, for example E, it will gonna loop until the user will get the correct answer. Else, if the user will input not in the list here, for example, he or she entered F, it will again loop because it's not in the variable. So the user should always input the correct answer. So D, the answer is D. We're gonna see out an image like I said before. Then you want to answer again. Yes, it will gonna go to switch case number 1 to 3. And if we choose to let G, the answer, so the answer for this is A, and it will gonna see out the image. So we will gonna X this one, so you don't need it. Do you want to answer again? Yes. Then let's proceed to subtraction of a set. It will gonna see out again a question. So the answer for this is A. Yes, it will gonna see out again the Venn diagram. Then X. If the user wants us to answer again, the user will input Y. Yes, that's all. That's all how our codes works.
So this is our presentation. We made a program that is dynamic as possible and simple, so that it can relate to other users and students that will use our program. So that's all, Miss. Thank you for
Thank you for listening to us.